falsetto, the vibrato or whatever.
The growl.
The growl?
All of it was
The
awesome.
growl.
Wonderful.
Thank you.
Practice a lot.
See, Grayson.
So
Not
we
Grayson,
are
Grayson.
starting this today. We are not going to finish it today. We're going to carry into next week. So what I would like to do is get through the first part, and then I can give you guys time to do that first chunk of homework, and then we'll pick up Monday with like the derivative piece. So we're going to go through the first bit of notes, and then we'll pick up next week.
Maybe this is like the main thing you were talking about.
So we are finally getting into derivatives. Derivatives
What's
are
under the radical?
That's discriminant.
Oh,
That's, yeah.
darn it.
So-
Nice try though.
derivatives are related to tangents, and we have talked about tangent lines, right? Remember way back at the beginning, well, that's a tangent function. When we were like estimating slopes of tangent lines, like we even, had those on the study guides, like finding the slope of a tangent line, which we related to instantaneous and average velocities. We did all that. So the tangent line to a curve is a point that touches, like if I had some random curve, if I wanted a tangent line at this point, that is a line that touches the curve at that point and bounces off. Okay, it doesn't really go through, it just touches only at that point. And in order for it to just touch and bounce off, it has to have the perfect slope. So there is a way to find the slope, which we did way back when we were estimating slopes of tangent lines, right? We made the tables and we would make our x's get closer together so we could get a better idea of what the slope of the tangent line would be. You guys remember doing all of that? And so we took 2 points. F of A was just the point that I was trying to estimate. A being the x value, f of A being whatever the function's equal to when you plug A in. And I would take some other point on my curve, so whatever that x value is and the y when I plug that in, and we would do the slope between them. And then we would set those up in tables and make our x get closer and closer to the number we are approaching. But now we have better language for that. That was a limit, right, when our x is approaching a number. So the limit as x is getting closer to A, so as I'm traveling in on this curve closer and closer to point A, of the slopes. Okay, that is the slope of the tangent line. So if I asked you to find the equation for the tangent line to the parabola y equals x squared at the point 1, 1. We've actually done this problem before, but I made you do tables as we approached one from the left, as we approached one from the right, the slope between it, the whole bit. Now, we know this is really just a limit. So we're doing the limit of the slopes. To find slope, how many points do we need? 2. So one of those is 1, 1. The other one,
Is x and y.
x and y, but what is y equal to?
F of x. Oh.
Yes, and specifically in this
X
problem,
squared.
Oh, my
y is x squared.
Shoot, that's genius. Substitution.
So I'm going to do the,
Bro.
the limit as x gets closer to what value?
X squared.
Mm,
No.
1.
Yeah, what?
X has to be getting closer to this point of 1 of the slopes between them. So our slope x
Squared minus 1.
over x minus 1. Y2 minus y1 over x.
Hey, it can't be 1.
Why do you... Oh, never mind.
Oh,
Am I good?
and now it cancels.
Yes.
Yes.
So can I plug in my 1?
No.
No, but just like we have done for our study guide, our test, the previous section, what do we do?
We factor the top.
Mm-hmm.
And get a hole.
Yes, what kind of discontinuity is that?
That
Removable.
Removable
Because
discontinuity.
he cancels.
Carson, you are too happy.
Dude.
I'm just too
Careful,
happy.
you might get a nosebleed.
Yeah,
Bro, I
Did that-
might.
Did that happen?
No. I was in the middle of the test and I was looking at the test.
Bro, we really missed that?
And it just started dripping out. Dude.
So is Carson's test just like blood covered?
We threw it away. He started over.
It was though, yeah. Because I tried to clean it off and it just smeared. That was
Why
terrible.
do you think it would just unseep into the paper?
I had faith.
You
Okay.
Faith is good.
So once we cancel, we can plug our 1 in and we get 2. So that means 2 is the slope of the tangent lines, right?
Equals 2. So then we have to plug in something for y and x to find the equation.
So now I asked for the equation. So how do we write the equation of a line?
Oh,
Y equals
y equals mx plus b.
So if we use the point that we were given, so y is 1, m is 2, x is 1 plus b.
B is negative 1. Oh my goodness. Oh my goodness.
So b is negative 1. So our equation is y equals 2x minus 1. Much faster than how we did this back at the beginning of the chapter, where we had to find 2 tables and plug in the x's to the equations to get y's, and then find all the slopes and look at what those approached. Much
That is
better
a lot faster.
method.
I like
Wait,
this.
Wait,
now.
this
we were finding an equation
Yeah.
before? I remember
We-
doing the tables, but did we make an equation?
A couple times we did, but we didn't every
This-
time.
Yeah.
No, I have it on my
can, though.
paper,
We
never
could've. Back then. Now we can't even.
Another notation for the same thing is using A's and H's instead of X's. So this says the limit is H approaches 0. F of X, or F of A plus H minus F of A all over H.
This
Okay.
equation looks familiar.
It should. We
Yeah,
did it
'cause
in
that's
pre-calc. I told you it was a difference quotient.
Didn't we do
And I
it?
said, in calculus, we'll learn what this is
And we
for.
did this at the beginning
We
of
did
this
this,
year.
yeah.
And we did this at the beginning in our pre-calc.
That's why we
beginning.
did it.
That's
Oh
why we
my
did it.
gosh.
I read
Ah.
all it, but I don't remember.
That's a genius move.
So it's saying if this is the point I'm concerned about, A plus H would be a little bit past that, right?
Sure.
Yeah.
If H is going to 0, what's happening to these 2 points?
You could connect. Oh.
If my H is getting smaller, it's getting closer and closer to the actual point.
Oh.
And so then your slope is the same type thing. F of A plus H minus F of A over A plus H minus A. And what happens to the A's? They cancel, so that's why it gets here. So they're equivalent. Both will find this the slope. It's really just kind of a matter of preference. This one is sometimes a little bit easier because the denominator is a single term, and so it's usually easier to cancel a single term than multiple terms where we have to factor everything first. So this has its advantage because the denominator turns out to be just a plain H. All right, so the first one we did is called definition 1. This one's our definition 2. So let's do one using that second method. This one's pretty. Okay, so I have a point 3, 1. The definition 2 is limit as H approaches 0. F of A plus H. Okay, so my function is 3 over X. I am replacing my X.
I could tell you're getting behind my head, but I was just thumbing through all of that.
A is just the number you're approaching. So F of A plus H.
Hey, I stopped listening. Why is H approaching 0?
Because you want the points to get closer to
Oh,
each other. So if my first point is at 3, the one a little past that would be 3 plus H. So we're plugging that in for
Oh.
X. So in this, the number we're approaching is our 3. So using the notation F of A plus H, so F of 3 plus H, to replace our X with the 3 plus H, minus F of A, but A is 3 over H. I was using the equation. But can we simplify that? What is...
So 1.
Mhm. Okay. Can I plug in my 0 yet?
No.
No. Okay. What other thoughts do you have?
3 plus H over 3H.
If you want to add or subtract with fractions, they have to have a common denominator. So instead of 1, can I write that as 3 plus h over 3 plus h?
Yeah.
Oh, okay.
Oh, so you're just finding it that way.
Whatever.
So because it's a minus, I'm going to distribute a negative. Therefore, limit as h approaches 0. What happens to my 3's?
Yeah.
They cancel, so I get h over 3 plus
Negative
h. Negative h, thank you. Okay, divided by h. This is like h over 1. How do you divide fractions?
1 over
Multiply by the reciprocal.
And plus put in the same line.
Negative h times over the 3 plus h times h over 1. No, 1 over h. Okay.
Are you with me?
Yeah.
1 over
Catch
3?
up.
That would
We're
be
a little
1
fast.
over, negative 1 over 3.
1 over 3? Negative 1 over 3? No, it wouldn't. Oh, would it? Yes, because it's here.
Okay. Yeah.
One.
Can we plug
Wait,
in
why do you? Oh, yeah.
the 0 now?
Yeah, I think so.
And if you put in a 0 for h, we get.
So, I kinda got a little lost when we started, putting it all over the common denominator.
Okay. So, alright, were you okay with the setup? And we said 3 over 3 is the same thing as 1, right?
Yeah, and why did we get the 3 over here plus h?
Well, you could have used 1 just from this, but the definition is f of a plus h minus f of a over h. A is the number we're approaching, so that would be 3 plus h minus f of 3 all over h. So the 3 plus h replace the x, minus then the 3 replace the x, so that's where
Wait, why doesn't the? How did the h 3h get under the 3?
Okay, I'm good.
Okay.
So, are we okay with this setup and why that's equivalent to 1? Okay, this is the same as 1 over 1, right? If we want to add or subtract fractions, they have to have the same denominator. This one had 3 plus h, so this one needs 3 plus h. So to not change our problem, we do it on top and bottom. That's how I got to this point. So, we just rewrote 1 as 3 plus h divided by 3 plus h. You agree that's the same thing as 1? Then, we said, okay, if I want to subtract, that's the same thing as plus a negative. The denominators match, so now we put the tops together. So 3 plus negative 3, those cancel, so all we had left was the negative h.
Step. First thing we did. How did that 3 over 3 plus h happen?
Because the definition says f of a plus h, right? A is the number we're approaching, which is 3, so that's f of 3 plus h. My function is 3 divided by x.
Okay.
So I'm plugging in.
I thought that only happened for the first part. Got it. Gotcha.
Alright. So what number did I just find? What does this represent?
Well,
The limit.
That's what my limit is equal to, which
Slope.
is my slope.
that
Okay.
M.
Yeah, I think that was like a cursive M. That's what we're going with. That was a cursive M.
I'm glad you added the slash on the bottom. So we knew it was slow.
Dude, that was like my handwriting on the
Okay.
That is so perfectly bumpy though. I love it. I love it.
So now if I am doing the equation y equals mx plus b, the original equation point, the y was 1, we got m to be negative 1/3, x was 3 plus b, so the y-intercept is 2. So the equation of the tangent line is negative 1/3 x plus 2.
I like this way a lot better.
Do you? I'm actually going to rework the exact same question using the first method, just to help you kind of decide. In general, I'm not going to care which method you use. As we do more and more of these, we're probably going to pick a favorite as we go through here. I do know that there's like the first homework question has A and B and it has you work the same thing using both methods. So that's why I'm going to do this one using both methods just to illustrate that.
This is not a calculus question, but is graph Okay, is he alive?
No, he's cooked. So
Alright, so if we look at this one, same thing but using the first method. So the first method is limit as x approaches a of f of x minus f of a over x minus a. Right? That was our definition 1 that we had. What's a?
3.
A is 3. So, we are doing the limit as x approaches 3 of f of x, so 3 over x, minus f of a, which is just f of 3. So you can write it as 3 over 3, or you can write it as a 1, doesn't matter, over x minus 3. Is everybody okay with this first one? Okay, can I change my 3 over 3 to a 1? Will that confuse anybody? If I want to add or subtract, what do we have to do?
You have to.
Common denominator. So it's much the same process. So this is like a 1 over 1. What am I going to have to multiply by on top and bottom?
X.
So we have 3 over x minus x over x divided by x over 3. So then when we put this together, we get 3 minus x divided by x over x minus 3. Not quite as nice. Do you know where we need to go from here? This is over 1. To divide fractions. Oh, I know what you were saying now. Sorry. We could have done. We
I was
could have worked.
thinking we needed to cancel.
Yeah. So 3 minus x over x times 1 over x minus 3. 3 minus x and x minus 3. Are those exact or do those cancel?
yes.
No. Negative x plus
Isn't
3.
it?
You take out a negative 1.
Okay. And then it would be a negative 3 and a positive x. Now do they cancel?
Yes.
Yeah. Okay.
So we have the limit as x approaches 3 of negative 1 over x. Can we plug in a 3 now?
Yes.
Yeah.
We get negative 1 over 3.
I forgot this was the same problem as last.
Yeah,
I was like, oh my
same
gosh, it was
problem.
the same answer.
That's crazy.
Do I have to finish writing the equation from here?
No.
That part's the same on both, right? The difference is how you find your slope. So, not that either one was especially beautiful, but this one is probably a little bit uglier because I had 2 terms on the denominator. I had to try to get to cancel. Typically, easier just to cancel an h. So the setup is maybe more obvious here as a slope setup, but the other one's probably going to be a little bit
I think I like both of these more than the table.
Sure.
Yeah, I don't like the
Yeah.
table at all.
So last piece I want to do today, I want to go ahead and relate this to velocities, and that'll probably be where we leave off, and then we'll pick up with derivatives on Monday. So we know that average velocity is just a slope, right? Instantaneous is what those slopes approach.
Yeah.
So if I wanted average velocity, you just y2 minus y1 over x2 minus x1. So when we are looking at these limits, when I'm doing the limit of these slopes, that is the instantaneous velocity. So average velocity is a single slope calculation, instantaneous is the limit of those. So exact same thing when I'm asking you to find velocities,
Just has a different name.
just has a different
So
name.
the
So a tangent line and an instantaneous velocity are the same. The slope of the tangent line is the instantaneous velocity. Okay. So probably our last example of the day. Suppose that a ball is dropped from the upper observation deck of the CN Tower 450 meters above the ground. Part A. What is the velocity of the ball after 5 seconds? Alright. And I am going to tell you, I want you to use the equation of motion. S equals 4.9 t squared. T is time in seconds, S is meters traveled. So I'm giving you an equation to solve.
450 and 0 is our first point, isn't it?
Well, that was like your starting point, so your starting height. We want the velocity after 5 seconds. So we can pick which way we want to do it. You want to go the second way? So that one is the limit
I think it's easier for my brain to understand.
as h approaches 0.
Or I meant the first way. It's the way
Oh.
but we can go this way.
Sorry.
The second way, in relative to what we just did, it was second.
Are you sure?
Yes.
Yeah. You mean the second one I did in that example?
Yeah.
Okay. So if I went with definition 2, A is the particular point in time. What point in time are we looking at?
5 seconds.
So we're doing f of 5 plus h minus f of 5 all over h. So I'm trying to write out exactly what I'm doing, maybe more work than you would have to show, but that way you understand where my numbers are coming from. So I'm doing the limit as h approaches 0. My equation is 4.9 t squared. So f of 5 plus h would be 4.9 times 5 plus h squared. The equation is f of a plus h. A is the time we're approaching. Minus f of 5. So that would be 4.9 times 5 squared over h. Okay, I'm okay if you jump straight to this step. I'm trying to show you where everything's coming from. Where would we need to go now?
Distribute.
Yeah.
The FOIL, sorry, is what I mean, is the word.
Yeah, start multiplying everything out. Can I just say, so this would be 25 plus 10h plus h squared? Can I go ahead and distribute my 4.9 through that? Okay, so we have 4.9 times 25, so 122.5, minus 4.9 times 10, 49h, or sorry, not minus, plus 4.9h squared. So that's the first one. Minus 4.9 times 5 squared. So, these cancel. And the limit h approaches 0 of 49h plus 4.9h squared divided by h. But now what can we do?
H over 1.
Yep.
No, or you
Well,
just cancel
you
out the
can,
H
or you
from
could
the
just-
49.
Yeah, it would come out of both of them.
Yeah.
So we would get a 49 plus 4.9h. And then if you plug in a 0, you get
49.
49.
49. Velocity, so meters per second. So, slope of the tangent line is the same as instantaneous velocity. Part B.
Oh, there, I didn't make enough space for part B.
Oh, shoot.
Oh.
Oh,
When it hits the ground.
when it hits the ground. So what would I have to do?
When the fix is 0.
Oh, whatever y equals 0.
Yeah, so first I need to know when it hits the ground, right? So it has to travel 450 feet, and I need that to equal my height. So we have to solve this. That doesn't look really beautiful.
You
What do
just
you mean?
divide.
Divide the
And then square
4.9.
root.
That's also awesome.
I don't know what when you say something doesn't look beautiful, my brain's like, oh my gosh, this is the hardest thing ever.
Oh, no.
You,
So,
you mean just because of the square root?
yeah. So we have 450 over 4.9 equals t squared and square root it. It is not a pretty number, so let's estimate it as best we can.
9.5831.
Alright, so let's say 9 point, we wanna go 58?
I did 31.
Yeah, you did more, it's fine.
You wrote on my paper for statistics I didn't give enough points, and now I'm like I usually do give 4 points. I don't know what I was doing.
Okay, so then what would we have to do?
Plug it back into that silly
Repeat, do
equation.
the exact same thing except change R5 to a 9.58. I think I'm actually probably going to stop here and not work that one out because we're going to do a lot more of these Monday. So I think this is where I want to leave it, but I want you guys to start some homework problems and make sure that we're on the right track.
Sorry.
So before I get into any more with this, I want you guys to try some.
That was a lot of slides.
That's a lot of slides. This will not be due for a while, but you could do up through.
Up to 3B.
I would say you could do up through problem 13.